In this project, we are going to simulate the heat transfer inside a vertical shell and tube heat exchanger.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by Mr. CFD. Or if you are watching the training video, click on the Mr. CFD logo and subscribe.
Now, in order to add a new material, all you have to do is to expand the material section, go over fluid or go over solid, right click on it and then select new. In the next part, if you click on each of the wall boundaries and then click on edit button, in the appeared window you will see a stationary wall motion along with no slip shear condition are defined.
After double-clicking on the Controls button, in the middle section of the software window, you can see that new part will appear. In the Appear part, you can see under relaxation factors for different parameters. Now these values are set here by the software automatically. You can change these values, which are between 0 and 1, by yourself for different projects you do. But it is highly recommended that you do not do that, since it may result in divergence.
There are two ways to check that your simulation process have reached convergence or not. Alongside checking the residuals reaching and nearing zero, you may define an arbitrary report over an arbitrary boundary in order to calculate different parameters like pressure, velocity, temperature, and see whether they reach a constant value or not. If yes, it may be a sign that your simulation process have reached convergence. However, you must check the residuals as well. To create such report, you can simply right-click on Report Definitions, go over New, and select one of the options available based on your simulation. Now, for example, in this slide, you can see the pressure changes of water flow inside the helical tube in 3D. And now in this slide, you can clearly see the temperature changes inside our computational domain, both in the helical tube and in the shell. Also, if you wish to extract 2D contours, you first have to create a plane. To do that, click on Locations and then click on Plane. Now here you can see the temperature changes inside our computational domain and over a plane which was created in the middle part of our computational domain. And finally, in this slide, you can see the distribution of velocity of the water flowing inside the shell over the plane which was created in the middle part of our computational domain. Finally, a summary of the settings and setup that we have used in our project is presented in this slide.
Obtain the mesh file and also the full training movie by purchasing this product.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.